Good afternoon. I would like to start by telling you that we usually take advantage of several chemical substances to do different routine tasks. Let me give you some examples. We usually take advantage of gasoline while we're driving a car. We use aspirin when we suffer from a headache, and also use acetic acid, which is generally found in a common seasoning like vinegar. But have you ever wondered how those compounds can be within everyone's reach? The process behind this is the purpose of chemical engineering. The main objective of chemical engineering is to design and implement process to transform substances into others more valuable for the daily life of human beings. Most of those transformations involves the operation of units where chemical reactions occur. These units are called reactors, and that's the topic I'm going to talk about. So, to define a reactor in simple words, a reactor is a physical place where a chemical reaction is carried out in a controlled manner. Now, let me elaborate on the concept of chemical reaction. A chemical reaction is the process through which one or more substances called reagents are transformed into one or more products. Let me go back to the first example I presented. When we are driving a car, gasoline is transformed into energy by the combination of gasoline with oxygen. This chemical reaction is commonly called combustion. In this case, the energy released from combustion is transformed into mechanical energy to move the car. Now, let me move on. Based on how a reactor is operated, there are three main types of reactors: the batch reactor, the CSTR, and the block flow reactor. In a batch reactor, reagents are loaded in the accurate quantities and concentrations in a vessel, and once conditions of reactions such as pressure, temperature, the nature of substances, agitation are provided, reaction occurs, and after a while there is a mixture of the expected products and low quantities of reagents that didn't react. Okay, let that picture speak for itself. This type of operation is found when people cook. You know, it is usually said that the kitchen is the first laboratory where people experiment with chemistry. So in this situation, a batch reactor may be any cooking pot with which people prepare, for example, rice. Now, let me move on to the second type of reactor. This is called the continuous stirred tank reactor, or its abbreviation CSTR. Take a look at this. In this reactor, reagents are continuously fed in the tank, and products and not reacted reagents are removed from the tank. In this type of operation, two critical features are assumed. First, there is a perfect mixture, which implies that concentrations in the outlet are the same as concentrations inside the reactor. Second, the system reaches the steady state, which means that all variables involved in the process do not change with time. This type of reactor is usually applied on industrial scale involving large quantities of reagents and products, and therefore a large size of the reactor. For example, this operation can be used for the treatment of wastewater. Finally, the third type of reactor is called the plug flow reactor. As you can see in the picture, this reactor is basically a pipe in which reagents flow through the tube and reactions occur along it. This type of operation is usually applied on continuous processes and industrial scales. For example, it can be used for the production of algae, which are useful for the production of a biofuel like biodiesel. So, to conclude, I've defined the term reactor. I have presented the three main types of reactors used in several processes, and I have illustrated some examples for its applications. Now, if you think you are planning of implement a process to produce something valuable for our society, you can think with more knowledge about which is the suitable type of reactor you need. That's all. Thank you.